Hi guys, welcome to today's video. So today's video is actually a follow-up of the series of the mini grid design course videos I promised on dropping, and David Udosen, my colleague, the mini grid design course, will also join me to share more light on what we're talking about today. So welcome, David Udosen.
Welcome, Dennis. Hi guys, welcome to.
Alright, thank you so much. So we'll be running through the solar cell, solar energy, and help you understand IP rating and systems, and also grounding, very important. Yeah, so let's get started. So for a solar cell, what you need to understand that is made up of a semiconductor material that is grown or absorbed by a conducting material. Now when the sunlight strikes on the N layer, which is quite thinner, it moves to the P layer. Now there is a rare electrical contact. Now that photons is reflected back if it's not used. Now when that process is done, it doesn't just go straight to the module. No, it has to encapsulate, it has to get to let's say 17 volts, 38 volts before it goes to the module. Yes, so you need to understand how the working principle of solar cell operates. Very important. So David, you help us have a better understanding of how solar energy is generated.
Right. Okay, so for solar energy, first of all, solar energy is generated in the sun's core, right? By the fusion of hydrogen atoms to form helium. Now, during this fusion reaction, part of the hydrogen mass is converted directly to energy, which is what we know as solar energy. Now, because the sun is very far from the earth, you have to understand that just a little portion, about 2 million of the whole sun radiation gets to the earth. However, this radiation is enough to power the earth 1,000 times more and even sustain it for the next 5 billion years.
Wow.
So, and it's estimated that if half of the surface area of Nigeria is used, it's installed, solar modules are installed on half of Nigeria, you have enough electricity generated to power the world.
Can you imagine that?
Yeah, that's right.
Wow, that's extreme. I'll tell you that there's a whole lot with solar energy. A whole lot. Alright, so very critical. So since you'll be working with solar system, now in the other video we gave a wrong view of the components of the solar PV system. So like I said earlier, if you have not done checking out the video, you can go back and you have a better understanding. Alright, so now IP rating, very important in systems. Now IP is just short form, it means ingress protection. Now you need to understand that the first figure is for the intrusion protection, while the second figure talks about the moisture. Now David, if someone is going to get an inverter and it says an IP rating of 21, what does that mean?
Okay.
In the real sense.
Okay, well, so first, just an overview, like we said, you have to understand that the first figure, or whichever figure you're talking about, is the characteristics keep getting stranger as they go down, right? So, for example, is the first figure, like I said, stands for ingress protection, solid protection, right?
Exactly.
So, 1 is no protection at all. 2 is protection of whole body parts. 3, for example, is protection from little. So it keeps getting, the diameters of the protection keeps getting smaller.
Yeah.
So for 20, what was that?
IP21
IP21. So the first 2 will mean that it's protected from like body parts of like 5 millimeters and above. And the 1 there, it means there's no protection from moisture. Wow. Yeah. So what that means really is that system should not be exposed to harsh weather conditions. It cannot function well in harsh weather conditions.
Yeah, exactly. Water should not touch it at all.
Yeah.
Even if the water from the AC,
Exactly.
it shouldn't touch it at all. Alright, so moving over to earthing. Now, in a photovoltaic system and even an electrical system, it's very critical to understand that electrical shock could occur as a result of surge from malfunctioning of electrical appliances. So for a photovoltaic system, let's just go straight to the PV system. We understand that earthing can either be done from the from the equipment point of view, okay, or from the system point of view. So just help us have a grasp of what this really means.
All right.
And how best it can be done.
All right. So first of all, we'll just talk briefly about the two. So for equipment earthing, it means you're connecting all metal parts of the system, right, to a single source and then connecting that to the ground through using an earth connecting rod or just something. The neutral part is connected to the earth connecting rod, which is buried in the ground. And first of all, you have to understand that this has to be buried deep into the ground because the earth has a zero potential, and this prevents, like he said, surges and even unbalanced load. So the second one, that takes me to the second one. The second one is the system earthing. Now for the system earthing, either the live or the neutral part of the equipment is connected to the earth cable and also connected to the ground.
Exactly.
Right?
Exactly.
So but all this are just done to ensure safety of the equipment in times of surge like thunders, storms and things like that.
Exactly. Please, when someone comes to install the solar PV system in your house, ask him or her, where's the earthing? Yes, prevent electrical shock and what have you. Alright guys, thank you so much. I believe you've learned one or two things from today's video. And many thanks to Rubitech, Engineer Matthew, All On Energy, my boss MGD, and
USAID, the European Union. These are big sponsors of the training and the exposure that renewable energy is getting in Nigeria. So many thanks to all of you.
Yeah, and GIZ.
GIZ.
Alright guys, catch you in the next video and be sure you're going to learn a whole lot. Like I said earlier, if you've not checked the other series, go check it. And the next video we'll talk about sizing. Alright, David Udosen, thank you so much for coming around. I really appreciate it.
Yeah, it's a pleasure.
Alright, thank you.
See you later.